Physics of solid. Materials have properties such as hardness, ductility, malleability, and conductivity. What makes a steel hard, lead soft, iron magnetic, and copper electrically conducting? These properties depend upon the order and bonding and the material. Classifications of solids. There are three types of solids: crystalline solids, amorphous solids, and polymeric solids. Crystalline solids. These have regular shape, regular pattern, regular arrangements of atoms and molecules. These include metals such as copper, iron, zinc, ionic compounds such as NaCl or sodium chloride, ceramics such as zirconia. Position of atoms is not fixed. It means when there is some heat given to them, the atoms vibrate at their position. These have strong cohesive forces. These exist between the atoms and hold them together. When excess heat is given, these forces break apart and the solid melts. These have definite melting point. It means that if a solid is a crystalline solid, that all of the solid would completely melt at a certain temperature. Crystal lattice. It is a three-dimensional solid obtained by repetition of a unit cell. A unit cell is a three-dimensional solid which consists of all the properties of a crystal lattice. Amorphous solids. Amorphous means form or structure. In these, no regular shape or arrangement of molecules exist like crystalline solids. There is no definite melting point. It means that if a solid is an amorphous solid, it would melt in a range of temperature. Glass, which is solid at room temperature, completely melts at 800 degrees centigrade. Polymeric solids. A structure that is intermediate between order and disorder is polymeric. These are partially or poorly crystalline solids. Polymeric solids are man-made. These are used to form synthetic materials like plastic and rubber. These are composed of simple molecules, carbon combined with oxygen, hydrogen, nitrogen, and other metallic and non-metallic elements. These small molecules are combined to make long-chain molecules. These have low specific gravity. Since gravity depends upon weight and weight depends upon density, and the density of polymeric solids keep on varying, so they have low specific gravity. These include polythene, polystyrene, nylon, and natural rubber. Now, a question may arise: difference between crystalline, amorphous, and polymeric solids. So, crystalline solids have regular arrangement, while amorphous and polymeric do not have a regular arrangement. These have strong cohesive forces, while amorphous have strong but weaker than crystalline cohesive forces, and polymeric solids have weak cohesive forces. Crystalline solids have orderly arrangement, arranged in three-dimensional solid, while amorphous has less orderly arrangement, and polymeric exists between order and disorder. Crystalline have definite melting point, while amorphous and polymeric do not. For example, crystalline exists diamond, amorphous has glass, polymeric has natural rubber.